Hello dear students, I am Professor Priya Kulkarni from Parvati Bai Genba Mose College of Engineering, Wagholi, Pune, and here we are going to start with the analysis and design of a flat slab. So this topic is there because we have designed the reinforced slab, we have designed pre-stressed slabs one way, two way in both the cases, but what is a flat slab? Okay, so the basic idea and whatever the criteria and whatever the IS code clauses are there, that we are going to study in this session, and in the next session we will solve one numerical that is for design of a flat slab. Okay, so what does the flat slab exactly means? It is a reinforced concrete flat slab. Okay, it is a reinforced concrete flat slab, also called as beamless slab. Flat means what? It is flattened. Okay, so why this slab is called as flattened or flat slab? Because it doesn't have any beams to support the slab. Okay, the slab is directly supported by columns. Okay, the slab is directly supported by the columns, it doesn't have any beams. And where do we get this type of slab? We get this type of slabs in long large conference rooms. Okay, just imagine that conference rooms, okay, or in the community halls, in wedding halls, okay, in the larger, in the large, where we do not want any uh, congestion because of the beams. Okay, in that cases we will go for the flat slab. Okay, uh, a flat slab is very complex structure and it is extremely difficult to determine the location and magnitude of stresses in the slab. So why it is very difficult to determine the location and magnitude of stresses in the slab? Because we just imagine a beam column junction. Okay, there we can calculate in the beam column junction. We assume that at the ends of beam we can or that particular structure can have a diagonal shear, and at the center of beam we have maximum bending moment. Okay, so we can identify those spots and those magnitudes for the standard cases. Means for UDL the maximum bending moment will be this, for point load maximum bending moment will be at the center and this much amount. Okay, and same for the shear. But in flat slab, because we doesn't have any beam over here, so we cannot identify or we cannot locate the exact location and magnitude of the stresses in slab. So this will be the challenging part in the flat slab. Okay, a part of slab is bounded on each of its four sides by center line of column and is called panel. Okay, now you can see here, you can see here. Okay, so this is a cut section of the slab. So this is the actual slab and it is cut. Okay, and these are the columns located at the appropriate junctions. Okay, now just look at the head of the column. Okay, this is column head. Okay, and that column head has one this type of what we can say a square or rectangular type of head. So that is known as the panel. Okay, a part of slab bounded on each of its four sides by the center line of column called panel. The flat slab is thickened close to the supporting columns to provide adequate strength in the shear and to reduce the amount of negative reinforcement in the support region. That's why, now just look at here. So why this type of arrangement is provided at the column head? So it is to avoid the negative reinforcement or negative movement and to give the adequate strength in shear. Okay, that's why it is made like this. Now the thickened portion, that is projection below the slab, is called drop or drop panel. So this part is known as drop panel. Okay. Also, in some cases the section of the column at top it meets the floor slab or drop panel is enlarged to increase the primary perimeter of the critical section, okay, for shear, and hence increasing the capacity of slab for resisting two-way shear and to reduce the negative bending moment at the supports. Okay, such enlarged portion, so such enlarged portions of the column at their top is called column head or column capital. Okay, so these are the basic requirement, or these are the basic part of the flat slab. Okay, so it has one slab and the main part is the column and this column head or drop panel. Okay, clear? This is the typical flat slab for a building. Okay, I'll show one more diagram, like this. Okay, so just look at this parking. Okay, in any mall you can see this type of parking. So this enlarged portion at the top of the column is called column drop or column head or column capital. Okay, this may be asked for MCQ. Okay, so this is the flat slab. Okay, it doesn't have any beam. The load of the column, the load of the slab is directly taken by the column. So we'll see this part on the one by one. So what is the invention, or where it, in what time it has invented, that is historical development of a flat slab is made in USA in 1906. Okay, it was the start of this type of construction. Many and Nicholas proposed a method of analysis for these slabs based on simple statics. This method is known as direct design method. Okay. So definition of flat slab. The term flat slab means reinforces the concrete slab with or without drop. With or without drop. So it will depend upon the situation and it will depend upon the location where we are going to use the flat slab. Okay, with or without drop, supported generally without beams by column, with or without flared column heads. So what is flared column head, we'll see in the next slides. So this is the basic definition of flat slab. Now what are the applications of the flat slab? So this is very important. In case of high rise building, thinner slabs are required so that additional floors can be added. Okay, so if you can compare between slab with beams, so we have that much thickness or that much area or that much space uh, wasted. Okay, so if we have to design or we have to go for a high rise building where we can provide or we have that ability to provide the smaller thickness slab and to get the maximum area or maximum space out of it, then in that case we'll go for a flat slab. The distance that be spanned by post tension slab exceeds the reinforcement construction with the same thickness. Okay, for increasing span length so as to increase the usable unencumbered floor space in the building. So means what we can get the maximum floor space in the building if we go for a flat slab. For diminishing the number of joints in the structure. Okay, for speedy construction of the project. Speedy constructions means what, we are directly eliminating the beams. That's why that reinforcement, placing of the beam, then concreting of the beams, that part will save the time. The amount of steel required is much less than normal RCC structure. The molds, what this point means, what we provide 4% to 6% of the steel reinforcement in the beams. Okay, so that much percentage will get saved if we go for a flat slab. The molds can be used a number of times as per the demand. What molds means, what the uh, formwork molds. Okay, so that molds can be used for number of times. Due to reduced beam section, load transferred to foundation is less compared to that of RCC. Generally or obviously, if we doesn't go for a beams, then it will directly save the cost, save the steel reinforcement, saves the time, and also saves the load. So if it doesn't have any load of the beam, then the load on the foundation is only of the slab and column. Okay, doesn't have any load of the beam. The structure is crack free as the whole structure is in compression. This is the main highlighting part of the flat slab. Since the whole structure is in compression, so it is crack free. It is crack free. Okay, the large span of slab can be obtained easily. Then what are the advantages of flat slab? So the construction of flat slab gives floor to floor height reduction. Okay, it is faster for the construction. It can provide early